All right, we're going to continue with section 15.2 in this video, and we are going to do number 12 on page 1015. Which says, in exercises 11 through 17, evaluate the line integral over C of f dot dr, where C is parameterized by r of t. And they give us f of x, y, z equals the vector y, x, and then z cubed, y, x, z cubed. And they also give us that r of t is the curve 1 minus t, t, and then pi t. 1 minus t, t, and then pi t, and t varies from 0 to 1. All right, so now we have a vector field, and we're integrating that over this curve C. So remember the approach that we use for that. So go back and look in your notes so we can kind of skip writing it down again, so I can make sure we can do as many examples as possible. But the line integral over C of f dot dr is going to be the integral from A to B of, you take your vector field F and you substitute in your X, Y, and Z from your curve C, and then you multiply that by R prime, you dot that, with R prime of T. So let's put all those different components together that we need. So F of R of T. So please be careful when you do F of R of T, because oftentimes people will take whatever the first component is here and plug it in there, and that, plug it in there, and that, plug it in there. But that's not how that works. We have to do X. This is X. So it's better probably if you write out your parametric equations versus writing it out this way. And then you see this X, that goes right there. This is Y, it goes right there. And this is Z, it goes right there. So every X that's up here gets that, every Y gets that, and every Z gets that. So this for us equals, now we're taking, this is supposed to be T. So that's T. This X is 1 minus T. And then the Z cubed is going to be pi T cubed. So pi cubed T cubed. That's our F of R of T. And then we also need R prime of T. R prime of T is going to be -1. And then 1. And then pi. And now we need the dot product of these two. So F of R of T dotted with R prime of T equals T times -1. So we get -T. And then 1 minus T times 1. So plus 1 minus T. And then plus pi cubed T cubed times pi. So plus pi to the 4th T cubed. So, and this is what we're going to integrate with respect to T from 0 to 1. So our integral, the line integral over C of f dot dr equals the integral from 0 to 1. And we can simplify this. We get a -2t right there. So -2t plus pi to the 4th T cubed plus 1. And we integrate that with respect to T. And now we're back in calculus 1 again. We just go through and integrate that. All right, so next we'll do another example. We are going to look at number 24. And actually, we may have enough space right here to do this. So number 24 says, in exercises 19 through 28, evaluate the line integral. And number 24 says the line integral over C of x dx plus y dy and plus xy dz, where C is parameterized by R of t equals cosine ti plus sine tj plus cosine tk for t between negative pi over 2 and 0. So the curve C, our parametric equation, x equals cosine of t. I lost it. Yes, cosine of t. Y equals sine of t. Let's just assume y sine of t. Yes. And then z is cosine of t. And t varies from negative pi over 2 to 0. All right, so when we have this set up, this is the m dx plus n dy plus p dz. So we are still doing a line integral of a vector function. All right, so now the way we do this is we just plug exactly what we see here into there, but we get that information all from our curve. So x is cosine t, dx is the derivative of this. So dx will be negative sine t dt. And y is sine t, dy is cosine t dt. And then x times y is cosine t times sine of t, and dz is negative sine of t dt. We put all that in, and we're going to integrate that from from negative pi over 2 to 0, excuse me. All right, so our integral is from negative pi over 2 to 0 of x is cosine t and times dx, which is negative sine t dt. Negative sine of t dt. And then plus y, which is sine of t, times dy, which is cosine t dt. I'm going to run out of space here, sorry. And then plus x times y. These two terms actually cancel, but too late for me to do anything with that now. So x times y is cosine t times sine of t. And then to save space, I'm going to go ahead and do this now, so I don't have to write all three terms out. Cosine t times sine of t times dz. dz is going to be negative sine of t dt. So I'm going to take that negative sine of t and multiply it by this sine of t and multiply that by the cosine of t. And it's going to give us negative sine squared t cosine t. Or actually, I'll just put cosine t times negative sine squared of t dt. That's the integral we will get there. And then we can simplify this. So I'm going to add these two terms. Now, if we couldn't simplify, then what you end up doing in a problem like this is you go through, you integrate this with respect to t. I mean, you can basically look at it as you're able to factor the t out from all, the dt, out from all of these terms. And you could split this up into 3 separate integrals and do it that way, but it's a lot easier just to leave them together since they all have the same balance, of course. So these two terms are going to cancel with one another, and we just end up with cosine t times negative sine squared t dt. So that equals the integral from negative pi over 2 to 0 of negative cosine of t times sine squared of t dt. And then we're back in calculus 1 again, and we can just do this with a u substitution. You can evaluate that integral. All right, so that concludes section 15.2, and we'll start 15.3 in our next lecture video.